Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Okay, so imagine waking up this morning and finding out that Google just made every AI coding assistant look like a calculator from the 90s. That's basically what happened.
All right, you've got my attention. What did they do?
They dropped Alpha Code 3. And Aiva, the benchmarks are absolutely wild. We're talking about an AI that can solve competitive programming problems at a level that would put it in the top 1% of human coders on Codeforces. Not top 10%, not top 5%, top 1%.
Wait, hold on. Top 1% on Codeforces? Those are people who live and breathe algorithmic challenges. That's a completely different league from autocomplete my function.
Exactly. And we're also going to talk about some fascinating new research on AI reasoning that actually made me rethink how these models work, plus a bunch of quick hits that dropped over the weekend. But first, let's dive into this AlphaCode situation, because it's genuinely a watershed moment.
Okay, so before we get lost in the hype, and I can already hear it building in your voice, let's establish what AlphaCode 3 actually is. This is Google DeepMind's latest iteration, right?
Right. So AlphaCode 2 came out back in late 2024, and it was impressive for its time, but AlphaCode 3 is a ground-up rebuild. According to DeepMind's technical blog post, they've completely redesigned the architecture using what they're calling hierarchical search with learned heuristics, which is a very fancy way of saying it doesn't just generate code, it explores the solution space like a human expert would.
Okay, break that down for me. What does that actually mean in practice?
So think about how a human competitive programmer works. You don't just start typing code immediately, right? You think about the problem, you consider different approaches, maybe you sketch out a few ideas, you eliminate the ones that won't work, and then you implement the most promising one. AlphaCode 3 is doing something similar. It's generating multiple solution strategies, evaluating them, and then committing to the best one.
And the benchmarks are backing this up? Because we've seen plenty of models that sound amazing in theory and then fall apart on real tasks.
Oh, the benchmarks are ridiculous. On Codeforces, which is like the Olympics of competitive programming, AlphaCode 3 scored in the 99th percentile. DeepMind ran it on 50 recent contests, and it would have achieved a rating around 2400, which is expert-level territory. For context, there are professional software engineers who can't reach that level.
Okay, that's genuinely impressive. But I have to ask, and this is the question everyone's going to be thinking, how does this translate to actual software development? Because competitive programming is very specific. It's algorithmic puzzles with clear right answers. Real software development is messy.
You're absolutely right to push on that. DeepMind actually addressed this in their release. They tested AlphaCode 3 on what they call real-world engineering tasks, things like debugging legacy code bases, implementing features from vague specifications, and refactoring complex systems. And according to their results, it's showing a 67% success rate on tasks that would typically take a mid-level engineer several hours.
67% success rate is interesting because that's simultaneously really high and not quite autonomous, right? Like, you still need a human in the loop.
Totally. And DeepMind is very clear about that in their documentation. They're not positioning this as a replacement for developers. Their explicit use case is expert-level pair programmer. You're still the one defining the problem, reviewing the solution, and making the final calls. But the amount of heavy lifting it can do is unprecedented.
So what's the actual model architecture here? Are we talking about a massive parameter count, or did they do something clever with the training?
Both, actually. The model is 250 billion parameters, which is big, but not absurdly so. The real innovation is in the training approach. They used a technique they're calling evolutionary program synthesis, where they basically had the model generate millions of candidate solutions to programming problems, and then used a reward model to identify which approaches were most effective. Then they fine-tuned on those successful strategies.
That's fascinating. So it's learned not just what correct code looks like, but the process of arriving at correct code.
Exactly. And you can see this in how it works. When you give it a problem, it doesn't immediately output code. It outputs a reasoning trace first. Here's my understanding of the problem. Here are the constraints. Here's why I'm choosing this approach over alternatives. And that reasoning is shockingly coherent.
Okay, I'm genuinely impressed. What about availability? Is this something developers can actually use, or is this another amazing demo that you'll never touch?
So here's the good news. It's launching in private beta starting today. through Google Cloud's Vertex AI platform. You need to apply for access, and they're prioritizing enterprise customers initially. Public access is slated for Q4 2026. Pricing isn't finalized yet, but the early indication is it'll be positioned as a premium service, probably in the range of $200 to $300 per developer per month.
That's actually more accessible than I expected for something this capable, though it definitely prices it as an enterprise tool, not something a hobbyist is going to spin up for fun.
Right. And there's a free tier coming for educational use, which I think is smart. Get students using it, train the next generation of developers who are comfortable working with AI assistants at this level.
So big picture, where does this fit in the landscape? We've got GitHub Copilot, we've got Cursor, we've got a bunch of other AI coding tools. Is AlphaCode 3 trying to replace those, or is it a different category?
I think it's a different category. Copilot and Cursor are fantastic for in-the-moment autocomplete and boilerplate generation. AlphaCode 3 is more like if you have a genuinely hard problem that requires deep algorithmic thinking, that's when you bring this out. It's a specialist, not a generalist.
That makes sense. Although I imagine once developers get access to it, they'll start finding creative uses beyond what DeepMind intended.
Oh, 100%. That's always how this goes. All right, shifting gears, let's talk about this new research on AI reasoning that came out of MIT and Stanford, because this one genuinely changed how I think about what these models are doing under the hood.
Okay, I saw the paper. Mechanistic Interpretability of Chain of Thought Reasoning in Large Language Models. Catchy title.
Right? Rolls right off the tongue. But seriously, this is important research. So you know how we've been using chain of thought prompting for a while now, right? You tell the model to think step by step, and it produces better results.
Yeah, it's become standard practice. You get better accuracy on complex reasoning tasks when the model explicitly shows its work.
Right. But nobody really knew why it worked. Was the model actually reasoning, or was it just pattern matching on what reasoning looks like? This paper digs into that question using some clever interpretability techniques.
And what did they find?
So they used a technique called causal mediation analysis to track how information flows through the model when it's doing chain of thought reasoning. And what they found is that there are specific attention heads in the transformer architecture that activate when the model is engaging in what they call symbolic manipulation. Things like carrying numbers in arithmetic, tracking variables in logic problems, or maintaining state in multi-step reasoning.
Wait, so there are actually dedicated circuits in the model for reasoning?
Kind of. It's not like there's a single reasoning module, but there are consistent patterns of activation that only show up when the model is doing chain of thought. And here's the cool part. When they artificially suppressed those attention heads, the model's performance on reasoning tasks tanked, but its performance on simpler tasks stayed the same.
That's actually really elegant experimental design. They're showing that these circuits are specifically tied to reasoning, not just general language understanding.
Exactly. And they did another experiment where they trained a separate probe to predict whether the model would get a reasoning problem right based solely on the activation patterns in those attention heads. And the probe achieved 89% accuracy at predicting success or failure before the model even output its final answer.
So they can look at the internal state and predict whether it's on the right track. That has some really interesting implications for reliability and monitoring.
Oh yeah. Imagine being able to flag when a model is uncertain or likely to make an error based on its internal state, not just the confidence score it outputs. That's a huge step toward more trustworthy AI systems.
So what's the broader takeaway here? Are these models actually reasoning, or are they just very good at pattern matching?
That's the million-dollar question, right? And the researchers are actually pretty careful about this. Their conclusion is basically, there are mechanistic processes happening inside these models that are functionally equivalent to reasoning, even if we can't say whether it's real reasoning in a philosophical sense.
Which is probably the most honest answer you can give. I mean, we can debate whether it's truly reasoning or sophisticated pattern matching, but if it produces reliable logical inferences, maybe the distinction doesn't matter as much as we think.
I go back and forth on this. Part of me wants to say, if it walks like reasoning and quacks like reasoning, it's reasoning. But another part of me is like, no, there's something fundamentally different about how humans reason that we're missing here.
I think that's a healthy tension to hold. We can appreciate what these models can do without anthropomorphizing them or overclaiming. They're powerful tools with specific capabilities and specific limitations.
Well said. Okay, one more thing from this paper that I found fascinating. They looked at how chain of thought reasoning emerges during training, and what they found is that it doesn't appear gradually. There's a pretty sharp phase transition around 30 billion parameters where the model suddenly starts being able to do multi-step reasoning effectively.
A phase transition? Like a sudden jump in capability?
Yeah, it's not a smooth curve. Below 30 billion parameters, chain of thought helps a little bit, but not much. Above 30 billion parameters, it becomes dramatically more effective. The researchers speculate that there's some threshold of model capacity where it can actually maintain and manipulate internal state effectively. And below that threshold, it just can't do it.
That's wild. It reminds me of those emergent properties we saw in earlier models where certain capabilities just appeared at specific scales.
Exactly. And it raises interesting questions about whether there are other capabilities waiting to emerge at even larger scales, or whether we're hitting diminishing returns.
Okay, so before we dive into quick hits, I want to circle back to something you mentioned earlier about AlphaCode 3. You said it outputs a reasoning trace before generating code. How does that compare to what this MIT Stanford research is describing?
Oh, great question. So AlphaCode 3's reasoning trace is explicitly trained. It's a deliberate output. What the MIT Stanford research is looking at is the implicit reasoning happening in the model's internal representations, even when it's not explicitly outputting its thought process. Two different things, but they're related.
Right, one is externalized reasoning, the other is internal computation.
Exactly. And there's probably a connection there, like models that are better at externalizing reasoning might also have more robust internal reasoning circuits. But that's speculation on my part.
All right, let's hit these quick hits because we've got a bunch of smaller stories that are worth covering.
Okay, first up, Anthropic quietly updated Claude's context window again. It's now 500,000 tokens, up from 200,000. No big announcement, they just updated the documentation.
That's just absurd at this point. That's like 1,500 pages of text. What are people even doing with that?
Legal document analysis, apparently, and codebase ingestion. I saw developers on Twitter talking about feeding entire repositories to Claude and asking it to explain the architecture.
Okay, that's actually pretty useful. What else?
Meta released an updated version of Llama 3.2 with improved multimodal capabilities. It can now handle video input, not just images and text. It's processing up to 60 frames per second and can do real-time video understanding.
Video understanding is heating up. Feels like every major lab is pushing on that right now.
Yeah, it's becoming table stakes. Oh, and this one's fun. Someone built a tool called LLM Debugger that uses a smaller language model to analyze the outputs of a larger language model and flag potential hallucinations or errors. It's open source and it's already getting a ton of traction on GitHub.
Using AI to check AI. I mean, it makes sense, but it also feels a bit recursive. Like, how do we know the debugger model isn't also hallucinating?
Right, it's turtles all the way down. But in practice, the idea is that you use a model fine-tuned specifically for critique and error detection, and you combine it with other verification methods. It's not perfect, but it's better than nothing.
Fair. What else you got?
OpenAI announced they're shutting down the GPT 3.5 API at the end of Q3 2026. They're pushing everyone to migrate to GPT-4 models or the newer GPT-4 Mini, which is cheaper and faster than the original GPT-4.
End of an era. GPT 3.5 was the workhorse for so many applications.
Totally. But honestly, GPT-4 Mini is so much better and it's competitively priced, so the migration shouldn't be too painful. It's just a milestone, you know? The stuff we were amazed by 2 years ago is now obsolete.
That's the pace we're operating at. Okay, what else?
There's a new AI safety benchmark called RiskBench that came out of UC Berkeley. It's specifically designed to test modders on edge cases and adversarial scenarios. Things like jailbreak attempts, subtle manipulation, and outputs that are technically correct but could be harmful in context.
That's really needed. Most benchmarks test for capability, not safety.
Yeah, and the initial results are not great. Even the best models are getting tripped up by a lot of these scenarios. GPT-4 scored 73%, Claude scored 78%, and Gemini scored 71%. So there's clearly room for improvement.
Though I guess the good news is we're identifying these weaknesses now rather than discovering them in production.
Exactly. That's the whole point of red teaming and safety research. Okay, last quick hit. Hugging Face launched a new feature called Model Gardens, where you can deploy and manage multiple models in a single unified interface. It's basically trying to be the Vercel of AI model deployment.
That could be really useful for developers who are experimenting with different models and want to A/B test or route traffic based on task type.
Yeah, and the pricing is actually pretty competitive. They're clearly trying to capture market share from the hyperscalers.
All right, so before we wrap up, I want to zoom out a bit. We've talked about AlphaCode 3, which is a huge leap in coding capabilities. We've talked about research that's helping us understand how these models reason. We've covered a bunch of incremental updates. What's the through line here? What's the bigger story?
I think the through line is that we're moving from the era of general-purpose AI that's pretty good at everything to specialized AI that's genuinely expert level at specific domains. AlphaCode 3 isn't trying to be a general assistant. It's trying to be the best coding AI, period. And that specialization is where we're going to see the most impact.
I think that's right. And I'd add that we're also seeing the infrastructure mature. Like the Hugging Face model gardens thing, that's not sexy, but it's important. It's making it easier for developers to actually deploy and use these tools in production.
Yeah, we're past the proof of concept phase. This is real infrastructure for real applications now. And the research side is catching up too. We're not just building bigger models and hoping for the best, we're actually understanding what's happening inside them, which is crucial for reliability and safety.
Agreed. And I think the other piece is that the economic model is starting to make sense. Like $200 to $300 per developer per month for AlphaCode 3, that's expensive. But if it genuinely makes developers significantly more productive, the ROI is there.
Oh, absolutely. If it's saving even 5 hours a week per developer, it pays for itself in a lot of organizations.
So where do you think this goes in the next 6 months? What are you watching for?
I'm really curious to see how developers actually use AlphaCode 3 once they get their hands on it. Like, what unexpected applications emerge. I'm also watching the research closely because I think that's going to unlock a lot of capabilities we haven't seen yet. And honestly, I'm waiting for the other shoe to drop from OpenAI. They've been pretty quiet lately, and that usually means they're cooking up something big.
Yeah, it does feel like we're due for a major announcement from them. I'm also keeping an eye on regulation. We've been in this relatively permissive environment, but as these tools get more powerful, I think we're going to see more serious conversations about governance and safety standards.
For sure, especially around things like model evaluations and safety benchmarks. That risk bench thing we mentioned, I could see that kind of testing becoming mandatory for deployment in certain contexts.
All right, I think that's a good place to wrap. Anything else you want to hit before we close out?
Just one thing. If you're a developer and you want to get on the AlphaCode 3 beta, applications are open now through the Google Cloud Console. The waitlist is probably going to be long, but it's worth throwing your name in.
Good call. And if you're interested in the research we talked about, the full paper is available on Archive. It's dense, but the figures are really illuminating, even if you don't wade through all the technical details.
All right, that's going to do it for today's episode of Semper AI Digest. If you enjoyed this conversation, make sure you're subscribed so you don't miss future episodes. And if you really want to help us out, share this with a colleague or friend who's interested in AI. Word of mouth is still the best way for us to grow.
Thanks for listening, everyone. We'll catch you on the next one.
Stay curious out there.